Hey everyone, and welcome back to AI Paper Podcasts. It seems like every single day AI is in the news for doing something amazing.
Mm.
But how about tackling complex scientific problems?
Mm.
That's what we're going to dive into today.
Yeah.
We're checking out this new paper, Adapting While Learning, Grounding LLMs for Scientific Problems with Intelligent Tool Usage Adaptation
Oh,
by Rose Yu and her team.
cool.
So what really caught my eye with this one is the idea of AI not just using tools, but like learning to use them intelligently,
Right?
like a human expert would. I
Yeah.
mean, that's a big step, right?
Yeah, it is a big step. And, we're used to LLMs being amazing at language tasks, but
Yeah.
when it comes to science, they tend to struggle with anything beyond the basics.
Right.
And the paper actually uses SciBench, which is this really challenging benchmark covering math and physics and chemistry.
Wow.
And it shows how LLMs just totally hit a wall with collegiate level problems.
So just giving them access to more tools like simulators or databases,
Right.
that's not enough. I would think that would be super helpful.
Right. You would think so, but it can actually backfire.
Really?
Yeah, the paper points out that if an LLM becomes too reliant on tools, it's like giving a student all the answers without teaching them how to think for themselves.
Uh-huh.
So they never develop that deeper understanding that you really need to solve problems independently.
Okay, so it's about finding that balance between using tools effectively
Yeah,
and developing those internal reasoning skills.
exactly.
It's kind of like how we learn, right?
Right.
Like we decide, when to use a calculator versus just doing the math in our heads.
Exactly. And that's really the core idea here.
Okay.
Teaching LLMs to adapt their approach based on how hard the problem is,
Uh-huh.
just like a human expert would.
Yeah.
It's kind of a fascinating shift in how we think about AI and problem solving.
So how do they actually do that?
Mm.
The paper mentions this two-stage solution, WKD and TUA.
Yeah.
I'm guessing those acronyms stand for something pretty important.
Oh, yeah, absolutely. So World Knowledge Distillation, or WKD, that's the first stage. So imagine the LLM is learning directly from solutions
Uh-huh.
that were generated using tools.
Okay.
So instead of just seeing the output, like the answer,
Yeah.
it gets to understand the underlying process.
Okay.
Like the why behind the answer.
I see.
It's like internalizing the expertise of the tool itself.
So instead of blindly using a calculator,
Right.
the LLM is like learning the actual math
Yeah.
behind the calculations.
Exactly.
That's much deeper.
Yeah, much deeper level of understanding.
Yeah.
And then comes tool usage adaptation, or TUA.
Okay.
And in this stage, they basically test the LLM on questions,
Uh-huh.
and they flag the ones that it gets wrong as hard.
Makes sense.
And then they specifically train it to use tools for those tough problems.
Oh, so it's like saying, okay, you struggle with this type of question, so let's bring in the right tool to help you out.
Exactly.
So it's learning when to rely on its own reasoning and when to call in reinforcements.
Yeah,
Like having a toolbox and knowing which tool to use for which job.
that's a great way to put it.
I like that.
It's a great analogy. The model isn't just mindlessly applying tools to every single problem.
Yeah.
It's learning to strategically switch
Right.
between direct reasoning and using a tool.
I see.
Almost like flipping a switch depending on how complex the problem is.
Uh-huh.
And actually, figure 1 in the paper shows this visually. It's really interesting to see how the model adapts.
Now, to really put this to the test,
Okay.
they didn't just use simple math problems, right?
No.
The paper mentions using all these different scientific data sets.
Yes.
From physics simulations to climate modeling.
Exactly.
Sounds like they wanted to really challenge this AI with real-world problems.
They definitely did. They even created their own custom data sets to cover a wider range of challenges.
Oh, wow.
One of them is called Muvoko, and it uses a physics engine to simulate real-world problems with things like friction and collisions.
Wait, they're making the AI deal with friction and collisions.
Oh.
That's getting pretty advanced.
It is, and then there's PDE, which focuses on solving partial differential equations, and those can be incredibly complex even for humans to solve.
Yeah, for sure.
And to top it off, they even created an epidemiology data set,
Oh, wow.
using real data to simulate disease spread in California.
So they're simulating pandemics now.
They are.
This is getting serious.
It is getting pretty serious. What other data sets did they throw at it?
Yeah, what else?
Well, they also included climate, which uses a neural network to predict temperature changes based on different emission scenarios.
Yeah.
But to provide some context, they also tested on established benchmarks like math, which is a collection of high school level math problems.
Okay.
And of course, SciBench, which we already talked about.
Okay, so a good mix of custom data sets
Yeah.
and established benchmarks.
Exactly.
I'm guessing they also compare their model to other big AI players like GPT-4.
Of course.
It wouldn't be a true test without seeing how it stacks up against the competition.
You're absolutely right. They wanted to see if their approach could not only improve upon like a basic LLM, but also outperform some of the most advanced models out there.
Uh-huh.
And the results, well, they're pretty compelling. On those custom data sets, the trained LLM consistently outperformed the base model, like sometimes by a lot.
Really?
Yeah. And what's even more impressive is that it actually beat GPT-4 and Claude on several of them.
Hold on. Beat GPT-4? That's a big deal. What kind of improvements are we talking here? Give me the numbers.
Well, on average, their model showed a 28.18% improvement in answer accuracy and a 13.89% increase in tool usage precision.
Wow.
Tables 1 and 2 in the paper lay it all out, and yeah, those numbers definitely caught my eye.
So it's not just about getting the right answer. It's about using the right tools at the right time,
Right.
becoming more efficient.
Exactly, and that's where this adaptive approach really shines. You know, the model's learning to strategically allocate its resources, so it's focusing its tool usage on those problems where it really needs the extra help.
That efficiency aspect is really interesting, especially with computationally intensive tools. You don't want the AI like wasting time and resources on problems it could handle on its own.
Right, it's like using a supercomputer to solve a simple arithmetic problem.
Total overkill.
Exactly.
No, what really struck me was that this research went beyond those like typical multiple choice questions.
Yeah.
They actually challenged the AI with open-ended problems, which feels like a whole other level of complexity.
Absolutely. Open-ended problems don't have a single right answer. They require the AI to consider multiple factors,
Right.
weigh different options, and even learn to prioritize certain outcomes over others.
Yeah.
It's a much more nuanced way of thinking.
Can you give me an example of the kind of open-ended challenge they use? Did they like ask the AI to write a screenplay or something?
Not quite a screenplay, but they did present it with a real-world problem.
Okay.
Designing a new shipping route to minimize temperature increase.
Huh.
You can actually see a visualization of this in Figure 11. So the goal was to find the most efficient route while also minimizing the environmental impact.
So like a classic optimization problem.
Exactly, with no easy solution.
Right. So how did the model handle that? Did it come up with any decent shipping routes?
Well, that's where preference learning comes in.
Okay.
The AI has to learn to rank different solutions based on like a set of preferences or criteria. So in this case, it needs to balance things like distance, fuel consumption, and of course, environmental impact. So there's no single right route. But some are definitely better than others based on those preferences.
So it's not just about finding a solution. It's about finding the best solution based on a set of values or goals.
Exactly. And what's really exciting is that even in this more challenging open-ended domain, their method showed real promise.
Oh, wow.
The quality of the solutions that the AI came up with was way better than the base model.
That's awesome.
Yeah, so this really highlights the potential for this adaptive learning approach to tackle a wider range of problems.
It's so cool to see AI move beyond those simple solve for X types of questions and really start grappling with those complexities of the real world. This paper really opens up a lot of possibilities.
It does. It makes you think, you know what, if we could apply this adaptive learning approach beyond scientific problem solving,
Right.
could we teach AI to adapt to challenges in areas like healthcare or finance or even art?
I love where you're going with this. Imagine an AI that could help doctors diagnose diseases like way more accurately, or an AI that could help financial advisors create personalized investment strategies. I mean, the potential applications are huge.
Absolutely. But this also brings up some important questions, right?
Yeah, you're right. As AI systems become more sophisticated and more integrated into our lives, we have to think carefully about the ethical implications.
For sure.
It's not just about building powerful AI, it's about building responsible AI.
Exactly. And that's a conversation that needs to happen across disciplines. So scientists, engineers, ethicists, policymakers all need to be involved in shaping the future of AI.
Well said. This deep dive has definitely given me a lot to think about.
Yeah.
It's exciting to see the potential of AI to like completely change the way we approach scientific problem solving.
Right.
But it's also clear that we're just at the beginning of a long and complex journey.
I couldn't agree more. And as we continue down this path, it's crucial that we proceed with both like enthusiasm and caution.
Yeah.
Always keeping in mind the potential impact of these technologies on individuals and society as a whole.
It's like we're standing at the edge of this whole new era
Yeah.
of scientific discovery
Right.
with AI as our partner.
Yeah.
not just a tool.
Exactly.
It's pretty exhilarating and a little bit daunting at the same time.
It really is. And that kind of brings me to a thought I want to leave our listeners with.
Okay.
We've been talking a lot about how this research tackles scientific problems.
Right.
But what if we could apply this adaptive learning approach to, like, other fields?
Oh.
Like, could we teach AI to adapt to challenges in healthcare
Yeah.
or finance or even art?
The possibilities seem endless.
They do.
Yeah.
It's almost endless.
Like imagine AI helping doctors diagnose diseases so much more accurately.
Right.
Or an AI that can help financial advisors come up with really personalized investment strategies.
Yeah.
I mean, this research could really be the foundation for AI that can, like, learn and evolve alongside us,
Exactly.
constantly adapting to new challenges and new domains.
And that's what makes this paper so significant. It's not just about, incremental improvements. It's about fundamentally changing how we think about AI problem solving.
Yeah.
It's about moving beyond rigid algorithms.
Right.
And towards systems that can truly learn and adapt just like we do.
I think this deep dive has really been an eye-opener for me.
Yeah.
We can all agree AI is evolving so quickly, and this research is like a perfect example of that.
Right.
It's exciting, it's thought-provoking,
Yeah.
and it leaves us with a lot more questions than answers.
And that's a good thing. The more we explore the potential of AI, the more we realize how much more there is to discover.
Yeah.
It's a journey of continuous learning for both us and for the AI systems we create.
Well said. Thanks to everyone for joining us on this AI Paper Podcast's deep dive into the world of AI and scientific discovery.
Yeah, thanks everyone for listening.
Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.
See you in the next episode.